Hello there. Our last lesson of this unit is trigonometry. Yes, I know the whole chapter is called trigonometry, but this particular one is called trigonometric ratios. And so I'm going to show you this triangle here and define some of the sides of the triangle. Obviously, it has to be a right triangle, so there has to be a right angle. And you already know that the side opposite the right angle always has the name of hypotenuse. The other two are called legs, but now in this particular case, they're going to be given as an additional name. But that depends on where you stand. You see, if you stand here, like this little person is, then this side over here is called opposite. And because adjacent means next to in English, then this other guy here is called adjacent. However, if you were to stand all the way over here where my finger is now, then all the way over here, this would become opposite. And because this is right next to my finger, would be called the adjacent. So it depends on where you are standing, whether it's here, this angle, or this angle. What about if you stand at this angle? Oh, no, never. You're never going to stand at the right angle. It'll always be one of the two acute angles, okay? So never go to there, okay? Never go to the right angle. Okay, so now I'm going to introduce you to this mnemonic device called SOHCAHTOA. And basically what it means is that this is sine, this is cosine, and this is tangent. These letters here all correspond to those three words there. So sine has an O and an H, opposite hypotenuse. Cosine has an A and an H, adjacent and hypotenuse. Tangent has an O and an A, which is opposite and adjacent. What you need to know is that this is always division, so opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, okay? So there is the mnemonic device. Sine is equal to the opposite over the hypotenuse. Cosine is equal to adjacent over the hypotenuse, and tangent is equal to opposite over adjacent. Now this is known as tangent, cosine, and sine. However, these are the abbreviated versions only because on your calculator, sine, cosine, and tangent have also been abbreviated, okay? So you may use one of your graphing calculators, or a regular scientific calculator will be fine, okay? That's the introduction. So now, let me go over some of the important features that you need to know about the calculator and the use, okay? First of all, when you are using the calculator, you must make sure that you are in degree mode. A little regular scientific calculator will have a letter D on it. D means degrees. What are others? Well, there are other such things as gradients and radians. Okay? If you're using one of these graphing calculators and you go to there, you're going to see that you need to check the mode. There is a mode button right here, right next to second function. And what you got to see is that the last person that used my calculator here was working with radians. It was probably a math analysis student. I need to be in degree mode. So let me go down and go over to degree and press enter. And now every time I turn it on, it will be back in degree mode and it'll be able to do the functions that I'm going to ask it to do. So let me clear that because I'm going to use it shortly. Again, must be in degree mode. Number two, if you are looking for a side, then you're just going to be pressing sine, cosine, and tangent of the given angle. They're going to give you an angle, so you just press the word sine on your calculator and then you solve the equation. I'll show you shortly. However, if you are looking for an angle, and I'll show you this in examples in a few minutes as well, you must always press the second function and then sine, cosine, and tangent. Second function is right up here, the blue button. So you would press second function sine. Now what you're going to see is that there's a little negative 1 there up at the top. That means inverse function. So all of these here, when you do that, will be sine to the negative 1, cosine to the negative 1, and tangent to the negative 1. That means that you are now looking for an angle because you are in an inverse mode, and then you'll be able to solve the equation. Okay? As far as what your answers will look like, well, when you are giving me a side, keep in mind that as a general rule of thumb, I'm going to be asking you to go to the nearest 10th, 2 decimal places. 1 decimal place. When you are giving me an angle, however, I don't want one decimal place. I am looking for a whole number. So if you end up with 58.7 degrees, that's really 59 degrees, and there will be a little bubble up on top, right? Okay, last item here before we go do some examples is that when you are solving the equations, they will look like this. And so therefore, when you say sine of 30 and then you end up with something like this, remember that when you cross multiply, if x is in the numerator, you are going to multiply. But if x is in the denominator, you are going to divide. Remember, denominator, divide, denominator, divide. And when x is in the numerator, you will multiply. You'll hear me say this shortly, okay? Last definitions for you is, sorry for my lack of artistic ability, but this is me with a lack of hair at this point. But I'm still smiling even in these times. This is your line of sight. If you were to rest your eyes straight forward, you would have a line of sight. And if you raise your eyes to look at something above, it is called the angle of elevation. If you lower your sight, then it's called the angle of depression. To be depressed, to depress is to be down, so you're going down. To elevate is to take something up. But it always must come from a horizontal line of sight, okay? There must be a horizontal line. Okay, let's get some practice going on here. So here is my first example. I have a 6, 8, 10 Pythagorean tripled, a triangle here, and I am going to be looking for the sine of A, the cosine of A, and the tangent of A. That means that because I'm working with letter A, I'm going to expect you to go draw yourself at A. So that little person is you. And remember, SOHCAHTOA. Yep, I'm going to keep SOHCAHTOA really handy for me. I'm going to make sure I remember how to spell SOHCAHTOA. And SOHCAHTOA means sine is equal to opposite over hypotenuse. So what is opposite of my finger? 8. What is the hypotenuse? 10. So you just write 8 over 10. And please don't ask me, Mister, do I reduce this fraction? When have you not? Always reduce your fractions. This will become 4/5. The cosine of A is ka, adjacent over hypotenuse. So adjacent to my finger is 6, hypotenuse is 10. So this is 6 over 10, which becomes 3/5. And tangent of this little guy here is opposite over adjacent. That would be 8 over 6, which is, of course, 4 over 3. Okay? So now I'm going to change it up on you, and I'm going to go away from A. Hey. So now I'm going to go over to B. Okay? So now I am standing at B, all you can be, right there. Okay, so now I'm going to find the sine, cosine, and tangent of letter B, which is right here. Okay, once again, sine is opposite over hypotenuse. Opposite of this guy is 6. Hypotenuse is 10. So 6 over 10, which is 3/5. Cosine is adjacent over hypotenuse. The cosine is adjacent over hypotenuse, which is 8 over 10, which is 4/5. And finally, the tangent of B, which is opposite over adjacent, that would be 6 over 8, which is, of course, 3/4. Interesting relationship, if you take a look at the sine and the cosine, is that the sine and the cosine are going to be inverses of each other. So 4/5, 4/5, and 3/5, 3/5 here. When you reverse the look at the different letters, right? One other thing to identify here is that, what about C? Remember, never go to C. It's always one of the two acute angles. Okay, well, here is my first example. I'm going to begin by drawing myself at the angle, always, which is right here. And then I'm going to identify the sides that I'm going to be working with. This here is opposite. This here is hypotenuse. So opposite hypotenuse, who could that be? Let's see, opposite, adjacent, no. Opposite hypotenuse, OH. Ah, that means it's the sine. Alrighty, so now I'm going to go write the sine of the angle, which is 28, is equal to the opposite over the hypotenuse. Okay, opposite over the hypotenuse, that means that I'm going to now cross multiply and solve for x. Now, the shortcut is that whenever x is in a denominator, you divide. Denominator, divide. Remember that, okay? So now let me go clear my calculator and press the number first always. 10 divided by sine of 28, enter. And you're going to get that x is equal to 21.3. Okay, now if you don't want to remember the shortcut of denominator divide, that's quite easy. Simply put a little 1 underneath this whole fraction here and cross multiply. Sauce, that'll give me x sine of 28 is equal to sauce 10. And simply just divide by the sine of 28. The sine of 28 cancel, and then you see it's 10 divided by the sine of 28 anyway, which would have given you 21.3 again on the calculator. But if you want the shortcut, denominator divide. Okay? Let's continue here. This next one, I am going to give you a 42-degree angle. In this case, if I draw myself at the 42-degree angle, I already did, this is called opposite, this is adjacent. Well, opposite, adjacent, here it is. That means it's tangent. Awesome. Let's go get the tangent. Tangent of the angle 42 is equal to the opposite over the adjacent. Oh, I know the shortcut. The shortcut is whenever the variable is in the denominator, I'm going to divide. So let's go divide. Remember, the number always goes first. So calculator time, clear. 12 divided by the tangent of 42, enter. 13.32, which means that b is equal to 13.3. Okay? One more. Let's see about this one here. Again, I'm going to start by drawing myself at the angle, which is right over here. What is this guy over here called? It's called the opposite. Opposite. This guy here is called hypotenuse. Okay. Opposite hypotenuse is opposite hypotenuse. Oh, it's sine again. Okay, let's go do the sine. So the sine of 24 is equal to the opposite over the hypotenuse. In this case, if I put the little 1 here, you'll clearly see why we multiply. Or you can remember, numerator multiply, denominator you divide. So all you got to do is press 20 sine of 24 on your calculator, and you'll get the answer. Let's see. 20 sine of 24, enter. And the answer is 8.13, which is 8.1. Remember, if you need to round off, you go ahead and do that. Okay, so now that we know how to find sides to the nearest tenth, I'm going to now show you how to find the angles. Now remember, whenever they're angles, that's the nearest whole number, and don't forget the little bubble, okay, the degree. Once again, I'm going to start by drawing myself at the angle that they are looking for, right there, and I'm going to notice that this is opposite and that this is adjacent. Opposite, adjacent, who could that be? Opposite adjacent is tangent. Yes, indeed. So you're going to write tangent of x is equal to the opposite over the adjacent. Now, you remember what I said about finding angles? What must you press on the calculator? That's right, second function whenever this is an angle that is missing. So I'm going to go clear my calculator, and I'm going to go second function tangent. Second function tangent. When you do that, you're going to see the little -1 there, okay? That means you are in inverse mode. You're looking for an angle. And then all you got to do is press 12 divided by 24 and then press enter. And you're going to see this is 26.56, which means that x is really 27 degrees. Okay, approximated, right? Whole number. Last one here. I'm going to begin by drawing myself at the angle up here. I'm going to identify that this is the adjacent and that this is the hypotenuse. I want nothing to do with the opposite, okay? So therefore, I am going to look for adjacent hypotenuse. For the first time. Cosine, adjacent hypotenuse, wonderful. Let me go get my cosine. Cosine of the angle is equal to the adjacent over the hypotenuse. Put a little 1, cross multiply. No, you don't, because I'm looking for an angle, right? And when you're looking for an angle, what should you do? Yes, hit second function, right? So here we go. Put the calculator over here, clear it. Second function, cosine. I'm now in inverse mode. 14 divided by 32, close the parentheses and press enter. 64.05, that means that x is equal to 64 degrees. So katoa! Have a wonderful day. Bye.